How is our use of critical raw materials developing? New and clean technologies demand increasing amounts of critical raw materials. We are just in the beginning of a major transition towards energy production through renewables and mobility with a lower carbon footprint. Not only is the industrial world making this transition, but the demand for energy and mobility is about to rise in emerging economies as well. However, the basis of renewable energy are raw materials. Solar panels, wind turbines, and electric vehicles require large amounts of technology metals for their magnets, their electronics, their surfaces, and their traction batteries. This is especially the case when we aim at a real decarbonization of society in order to combat climate change. In every scenario, our demand for raw materials will grow substantially. In order to reach a zero carbon future, it will actually be sixfold of today within the next 20 years. For some minerals, this growth is extremely pronounced. Lithium demand, for example, could be the 40-fold of today in a sustainable development scenario, and cobalt demand the 20-fold. In a conservative scenario where we operate as today, which would mean facing a global temperature increase of 6 degrees, lithium demand will still grow more than 10-fold by 2040, and cobalt demand 6-fold. Other elements with a highly increasing demand for low-carbon technologies are graphite, nickel, manganese, and the rare earth elements. Many of the metals we are talking about are supplied by only a few countries, and often one single country is the absolute leader in supply on the global market. Many countries dominating the supply of critical raw materials are developing and emerging economies. Cobalt, for example, is mostly resourced in the Democratic Republic of the Congo, an especially poor country. China is an especially prominent supplier of many critical raw materials. When China introduced temporary export limits on rare earth elements, the prices of these metals skyrocketed. Also in the trade war between the US and China, rare earths are a major issue. The leading position of China in rare earth supply is due to a variety of factors. It would not be impossible to mine rare earths elsewhere, but establishing mining facilities, for example in Europe, that meet environmental and social standards is a difficult undertaking. Also, fluctuating prices of raw materials do not encourage long-term investments. You will learn more about this in the upcoming modules. There is a very physical basis of our technologies. Every high-tech product consists of various raw materials, which must be extracted, processed, shipped, and manufactured before they become part of our lives. This figure shows the so-called story of stuff, a material from its beginning on the left, the mining, to the right, its end of life. At first, resources from the ground are processed into basic materials, from which product components or primary products are made, for example, a smartphone display. These primary products are combined with others to create the final product, whose raw materials at the end of the product life cycle are either dissipated into the environment or go back in the economic cycle. High technology products today are truly global. That means their raw materials and components come from all over the world, and together they might have actually traveled the world several times. One of the major problems contributing to a material's criticality is that a material's inclusion into certain products decreases the concentration of this material on a global level. Materials are heavily concentrated in mines first, but then are distributed in small amounts into billions of products, such as smartphones. This dispersion is one of the causes that recycling of the raw materials is often not feasible. We need critical raw materials for a sustainable future, but their supply is complex.